Hi there everyone! Welcome back again with another video. This is Math with Teacher Riva. Yes, you are again with me as we learn another set of math concepts, all written and said in English. Let's make math easier. Okay? Would you agree with me? Alright, that is good. Now, we are up to another video. Please do watch and listen to this video so that you will learn something for today. And of course, I hope you are all doing well today and that you are all in good condition for studying. Alright, before we review our topic last time, let us first watch a video of the past lessons that we had and try to relate it on our next lessons to come. Okay? So, let's view and watch these videos. Enjoy!
Between 0 and 90, an angle is acute. This angle's small and skinny and kinda cute. It looks like a V or the top of a Y, or the angles that you see eating pizza or pie.
Angles are measured in degrees, and here's how to remember them with ease.
See, when an angle measures 90, do we call it right? You can tell this angle just by sight. It looks like an L or the corner of a square. You're looking at them when you're walking up the stairs.
Angles are measured in degrees, and here's how to remember them with ease.
From 90 to 180, an angle is obtuse. This angle's kinda fat, it's got a big caboose. Like the hands on the clock when it's 1:45, or the antlers on the head of a full-grown moose.
Angles are measured in degrees, and here's how to remember them with ease.
To measure an angle's degrees with a protractor, place the vertex at the hole in the center. Line up one ray at 0 on the protractor. Remember that the 0 can be on top or under. Count up to where the other ray points at the number. That will be the angle's measure.
Angles are measured in degrees, and here's how to remember them with ease.
So, there you have it. You have watched the videos that is somehow related to our topics for this unit. Alright, let's begin our recap on what we have studied the last video. We have mentioned and studied about equiangular quadrilaterals. Again, this is quite difficult for you to say, but let's try to do it one more time, okay? Equiangular quadrilaterals. Your turn. Okay, squares and rectangles. Squares and rectangles. We have studied about equiangular quadrilaterals, squares, and rectangles. All of these figures are all related to our main topic, which is the angles. Look at the figures again. I know I have showed to you this one before, but let me show you it again. 2, 3, and 4. All of these figures are examples of equiangular quadrilaterals. Again, these 4 figures above are examples of equiangular quadrilaterals. These quadrilaterals are composed, or they do have 4 angles. Again, they form and they have 4 angles. Let's try to look at it again, huh? 1, 2, 3, 4. Another one. 1, 2, 3, 4. 1, 2, 3, 4. And the last one. 1, 2, 3, 4. All of them have 4 angles, and once you can see or identify quadrilateral that has 4 angles, it's automatically called equiangular quadrilaterals. Let's check. The question would be, is it an equiangular quadrilateral? You would answer me with a yes or a no, or let's have check for yes and X for no. Alright, our first figure is a clock. Let's look at the shape of the clock and not the ones inside, okay? Let's have the clock. Is the clock an equiangular quadrilateral? Yes or no? Okay, what's your guess? They are, or it is, not an equiangular quadrilateral. It is not an equiangular quadrilateral. It is not an equiangular quadrilateral because it is shaped like a, or it's not like, but it is shaped as a circle. And a circle does not have any angles. Okay, let's move on. We have the next picture. Cone. Cone. Is the cone an equiangular quadrilateral? Yes or no? Check or X. It is not an equiangular quadrilateral because its shape is cone, and angles found in the cone is usually 3, just like the same with a triangle. The triangle have 3 angles only. So, it is not an equiangular quadrilateral. It's a big X. Alright, next we have a bed. This bed has a lot of angles, but let's try to see one shape or one part at a time. Let's look at the legs. Do they have equal angles or 4 angles? Or try to look at the bed itself. Does it have 4 angles? Yes, it has. So, therefore, it is an equiangular quadrilateral. Okay, can you get it? It's very easy. Okay, how about this laptop? Is this laptop an equiangular quadrilateral? Yes or no? Yes, it is an equiangular quadrilateral because its shape is like a square, a rectangle, and as you have seen, a rectangle has 4 angles as well. Alright, how about this stop sign? How about this stop sign? The stop sign is shaped like what? How many sides does this stop sign has? They have, let's count together, okay? Let's have 1, 2, 3, 4, 5, 6, 7, 8. It has 8 sides. Now, what do you call if it's 8 sides? It's octagon. And it's 8 sides. Do you think it has 4 angles? No. An octagon does not have 4 angles. Because it already has 8 sides, we don't call it an equiangular quadrilateral. It is not an equiangular quadrilateral because again, its size is already 8 sides. Good thing if it has 4 sides, you still can call it equiangular quadrilateral, but it does not have 4 sides only. So, it is not an equiangular quadrilateral. Okay. Let's review on squares and rectangles. Squares and rectangles. Squares, you have equal sides, as I have mentioned last time. Alright? If you can see object that has equal sides, it is safe to say that this is a square shape. If again 4 sides are equal, then it must be called a square. Okay? And if you can see objects that has short sides and long sides to each, then it is safe to say that it is called a rectangle. Okay? If it has 2 short sides, which is this one, the height, and the length, which is long, it is called rectangle. But if it has equal sides, do not have long and short side, it is a square. Okay? Okay. Now, let's have a quick review again. Is it a square or a rectangle? Tell me if the figure shown is a square or a rectangle. Easy peasy. Okay, let's have the first picture. The television. Television, square or rectangle? How many sides does the TV has? It has 1, 2, 3, 4. Are the sides equal? Yes, so it is a square. Very good. How about this notebook? How many sides does this notebook has? Let's count together. 1, 2, 3, 4. It has 4 sides. Are they equal? Yes, they are. So, it is a square again. These two objects have 4 sides and equal sides. Therefore, this is a square. How about the next one? Is it a square or a rectangle? Look at this ruler. How many sides does this ruler has? How many sides? 1, 2, 3, 4. It has 4 sides. Okay. Now, are they equal or not? Are they the same or not? They are not the same, so it is a rectangle. Okay, it is a rectangle. Next, this door. How many sides does this door has? Let's count. It has 1, 2, 3, and 4. It also has 4 sides. But are the sides equal? No, they are not equal. It has 2 short sides and 2 long sides. Therefore, it is a rectangle. 4 sides having no equal sides are rectangles. How about this one? Is this flag a square or a rectangle? It still has 4 sides, but it does not have equal sides. So, it is a rectangle still. And the last picture. These dices. Are the dices? Do the dices have 4 sides? Yes, they have. Do they have equal sides? Yes, they do. So, which means these are square. Square. Do not forget, a rectangle has 4 sides but don't have equal sides, but instead have short sides and long sides. However, a square also has 4 sides, but the sides are equal. It's the concept of square and rectangle. Now, let's move on to our next topic. This is new topic, but I'm sure it's very easy for you. Try to identify what are the pictures that I will show and will be flashed on your screen. What is this? Very good. It is a clock. Great job. How about the next one? It is a donut. Good job. How about the next one? What is this? It is a ball. Very good. How about this? It's a 1 round pizza. Great job. And how about this one? It's a piece of cookie. Now tell me, what is something in common among these pictures? What is something in common among these pictures? Right, they are all shaped as square No, they don't form square. Are they rectangle instead? No, they are not. Then, what are they shaped like? They are shaped as a circle. Very good. Again, everybody, say it with me. Circles. Very good. Now, C-I-R-C-L-E-S. Circles. We are going to focus today about the circles. Circles have different components. Let's do components of a circle, or in other terms, what are the parts of a circle? Let's start with the first one. We have here a circle and a point and a letter. Okay? Let's try to point the center. The center must be here, so we need to move it. The point that is the same distance from any and all points of the circle is what we call center. Okay? This dot should be here near the A so that it will become the center. Next, this black covering the circle is what we call the circumference. Repeat after me. Circumference. Okay, the center is here while the circumference is outside. The circumference is only for circles, which means oval does not have circumference. Square does not have a circumference. Rectangle does not have a circumference. Only circles have it. Okay? What is this? Center. And this one? Circumference. Great job. Next, let's move on to the third part or component of the circle. Okay, you have here point C, the center, and point D. Okay, from point D to point C, or from point C to point D, it is what we call diameter. Repeat after me. Diameter. Okay, it's the diameter. Line C to line D, point C to point D, point D to point C is the diameter. It is the line segment that connects two points of a circle and passes through the center. It will only be called a diameter if it really passes the point at the center. If it connects two points, any points in the circle, but did not pass the center, it is not a diameter. Okay, again, what is this part? Diameter. Great job. Let's move to the fourth part of the circle. We have a circle again. We have the center, and it's connected to another point in the circle. That's line AY. Line AY is what you call radius. Again, radius. This radius is the line segment or the line that connects the center of the circle to a point of a circle. Diameter is when you connect 2 points in the circle, right? But radius connects only 1 point. And it should start through the center again. If it connects to other point in the circle, it's not a radius. It must start through the center before it connects to another point in the circle. Alright, this is the radius. Again, one more time please. Radius. Okay, great job. Now you tell me what is right. I will show you 2 figures. This is point K or center K, and this is another figure for this K. You tell me which one is right. Is it figure 1 for center or figure 2 for center? Alright, it's figure 1. Great job. The center must be placed over here. Good job. Next, what is right? Is it the first figure or the second figure? What is right as a radius? Again, radius. Is it figure 1 or figure 2? Okay, it's figure 1. Yes, a radius must pass through the center before it connects to another point in the circle. Okay, let's have the last one. Figure 1 and figure 2 for diameter. What is right? It's figure 1. It should pass through the center before it connects to 2 other points in the circle. There you have it. The right figure goes to figure 1 for diameter. Okay, let's review vocabulary and important words for today. Repeat after me. Say, circles. Okay, good job. Radius. Well done. Circumference. Good job. Center. Great job. Diameter. Well done. Those are the important and new set of vocabulary words learned for today. That's it for today's video. I hope you have learned something, and if you've missed some important points, you can watch the video again. This is Math with Teacher Eva. Goodbye everyone, and keep safe always. Bye!